In section 1.1, we did a little bit with graphing on number lines. In section 1.2, we're going to talk about graphing in the Cartesian coordinate system. That sounds fancy. Anybody know what the Cartesian coordinate system is? You know what it is, you just didn't know the name for it. The Cartesian coordinate system looks like that. Cartesian coordinate system. Anybody know why it's called Cartesian? Had to do with who invented it. Who invented it?
Cartesian?
Cartesian, close. Rene Descartes is the person who invented this. Anybody ever heard of Rene Descartes before? What did Rene Descartes do?
Philosopher, wasn't he?
He was mostly known as a philosopher. He did math for fun. That was kind of his entertainment. His relaxing thing was to do math. Just like you, right?
Yeah.
He kind of did math for fun. All right, so tell me what you know about this. What do you know?
There's a X and a Y.
Okay. The horizontal axis is quite often called the x-axis. And the vertical axis is quite often called the y. But we won't always use x and y in this class. We'll sometimes use other letters, but that's the idea. What else do you know? What's that?
There's positive.
There's positive and negative. Which way is positive? Which way is negative?
Positive is right. Negatives.
Okay. So typically we put little tick marks on our graph here, and we might call this 1, 2, 3, 4. And then when we go to the left, we got negatives. Negative 1, negative 2, negative 3, negative 4. How about the y-axis? Positive is up. 1, 2, 3. And negative is down. Negative 1, 2, negative 3. Okay. What else do you know about it?
There's 4 coordinates.
Not
Quadrants.
4 quadrants. Very good. What we call quadrants. So what are the quadrants?
There's the area.
They're the 4 areas, correct. Which one is quadrant 1?
The top left.
Top right.
Top right is quadrant 1. So this area is typically called quadrant 1. And then which way did I go for 2, 3, and 4?
Down, left, up.
Counterclockwise. So this area is called quadrant 2. This one's called quadrant 3. And this one's called quadrant 4. And truthfully, that's not very important with algebra. The quadrants become very, very important when you study trigonometry, but we won't do any trigonometry in this course. But those are the quadrants. All right. Anything else you know?
Graphing?
We use this for graphing. What kind of graphing do we do with this thing? We graph all sorts of objects. I heard slope, which refers to lines. I heard parabolas. We do parabolas. And there are lots of other shapes. That's true. What else?
Can it only be a straight or diagonal
Oh,
straight line?
a lot of this course, what we're going to study is we're going to study straight lines. That's true. But it doesn't have to be straight lines. I mean, I could draw something on here that's a curve. And we will talk a little bit about curves in this class. But primarily, we're going to deal with lines. What else do you know? Anything? You've given me most of the important things already. Okay. One thing that's talked about in the book, there's a special name for that point right there. What's that called? Point where they cross. That one's called the origin. The starting point, the origin. All right, so a lot of what we're going to do today is we're just going to plot points on these axes. And when we plot a point, we might draw like a dot, say, right there. And then we label that point. How would you label that point?
It would be 2, 1.
Why 2, 1 and not 1, 2?
Because you're going over first, then up.
You go over first and then up. That's exactly correct. And a lot of people screw that up sometimes.
I do, and that's why.
You got to think about it carefully. So you start at the origin, you go over 2, and up 1. The left and right comes first. So this would be the point 2, comma 1. Oops, 2 comma negative 1. I wrote 2 comma positive 1. We start here, we go over 2, and then up 1. So that's 2 comma 1. Where people usually mix up the x's and the y's are points that are right here on the axes.
And that would be the other way, right? That would be 0, negative 3?
That would be 0, negative 3, absolutely. Because how far right and left did you move? None. You didn't move left and right at all. You only moved straight down. But I will see a lot of people write negative 3 comma 0 here. But that one is 0 comma negative 3. You started at the origin, you went straight down. How about if I asked you to graph the point negative 4, negative 2? Where would the point negative 4, negative 2 be? Which
Second quadrant.
second quadrant?
Third.
The third quadrant?
It's the third quadrant.
Third quadrant,
Negative.
over 3, up 2.
Down.
Did
Wait,
you
you
say
said
negative
positive
3,
2, right? It'd be
positive
over.
2?
I said negative 4, comma negative 2, I think is what I said.
So it's over and down.
Over 4 down.
Over 4, left 4, and then
Down 2.
down 2. So the point negative 4, 2, I would start at the origin. I would go left. Yeah, I should have written it down because people
I
got
got
confused as to what I said.
2.
And down 2. So negative 4, negative 2 would be right there. Okay. The next thing we need to talk about for a second here is something called the independent variable. And the dependent variable. Oh, I do have one other question back to these things. There's a name for something like this, besides just a point. They're also called ordered pairs. Why would we call them ordered pairs?
That's the way you would do it. That's
Well-
how you know where that is.
Because it's a pair because there's how many things?
2.
2.
Order X1.
And they're in order, x and y. So negative 4, negative 2 is different than negative 2, negative 4. The order that you write them in does make a difference. Where would negative 2, negative 4 be?
Over negative 2 down.
It would still be in the third quadrant, but it would be in a different spot, wouldn't it? It'd be right about here. Negative 2, negative 4. So they are different order matters. Okay, independent variable. What we're going to deal with in this class quite often is we're going to deal with data. And we're going to see some examples of data here in just a minute. When you have data, there's typically one variable that's the independent variable and one that's dependent. Anybody know what the difference means between those two things?
One relies on the other.
One relies on the other. So the dependent variable relies upon the independent variable. That's true. That's what you're going to say?
The independent can stand alone.
The independent can stand alone. Okay. If I have data, say in a graph perhaps, which variable is the independent variable?
Y.
Nope, you had a 50-50 chance you made it back in. The independent variable, this is x, usually. Again, quite often we won't use the letter x. But the way to think of it when you're given a word problem, and we're going to see some word problems here in just a minute, is this is usually the thing you know. And conversely, the dependent variable is usually y, and this is usually, usually wrong, the thing you need to figure out. And this will make more sense here in just a minute when we look at some examples. Okay, so let's take a look at problem number 1. Very similar to what we've been doing. I got a grid there. I got some points labeled. Somebody tell me, where is point A?
Negative 4, negative 3.
Negative 4, negative 3. I agree. All right. How about somebody else? Tell me where B is.
0, negative 5.
0, negative 5. Okay, you just made a very common mistake. 0, negative 5 would mean don't move left and right and go down 5.
So it'll be negative 5, 0.
Negative 5, 0. Very good. And like I say, that's where most people make the mistake of switching the x's and the y's when one of them is 0. That one is negative 5, 0. It's 5 to the left. Don't move up and down. All right, I need another voice for C.
-2.
Or -2.
Okay. I think -2, 4 was correct. -2, 4 would be there. Remember, you do the left and right first. If you gave me 4, -2, 4, -2 would tell me move to the 4 to the right,
Yeah.
and then 2 down. All right. So again, watch that. Very easy to get them backward. Always make sure you're doing the left and the right first. Continuing on with D.
1, 3.
That's 1, 3. Excellent. E.
0, -2.
0, -2. And finally, there's an F.
5, -4.
5, -4. Very good. Anybody have questions on any of those? Okay, problem 2 says, identify the independent and dependent variable. A is, let N be the number of hours a student studies for a quiz, and let S be the student's score on a quiz. Okay, so you guys are students. What are you going to know? Are you going to know how many hours you study?
Yes.
Or do you know your score? You're going to know how many hours you study. So which one is that?
Independent.
That's the independent. So N is the one you're going to know. You're going to know how many hours you studied. Based on how many hours you studied, that's going to tell you your dependent variable, which is your score. So independent is N. Dependent is S. Part B. Let T be the tuition in dollars for enrolling in C credit hours of classes at Corning Community College.
Credit hours for the independent.
Credit hours is independent. Typically, you're going to know I signed up for 6 credits. Once you know you signed up for 6 credits, what's going to happen?
Then you need to find out how much.
Then the college is going to send you a bill. That's correct. So I would agree in this case that the thing I'm going to know how many credit hours I signed up for. So I think independent is C, and dependent equals T. Okay, so notice that it doesn't make a difference which order they show up in the sentence, does it? Because for this one, for part A, N showed up first, and N turned out to be independent. But for the second one, T showed up first in the sentence, and T turned out to be dependent. But the order that they show up in the sentence makes absolutely no difference. You've got to think about which one am I going to know and which one am I going to figure out. All right, and finally part C. Let A be the floor area of a classroom, and let N be the number of students who can comfortably fit into the classroom.
N is the independent. And A is dependent. So I would know the floor area. It's the reverse.
Okay, so if I'm the college, think about how do I determine how many chairs to put in a room? Do I first pack in how many students I think I can and then figure out the floor space? No, I think I figure out the floor space first, and then I say, well, each student is going to need so much room. So I think I figure out the floor space first.
One like that was missing.
Right, that one can be a little confusing. So I think I figure out the floor space first, and then I know how much space each student is going to take, so I can divide and get my number of students that can fit in a room. How many students can fit in this room? Is there a fire code thing around somewhere? I don't see one. So I don't know. Anyway, I think in this one, A is independent and N is dependent. Not your car? Okay, describe what the given ordered pair means. Let C be the total cost in dollars of buying N pencils. What does the ordered pair 5, 10 mean? Well, the first thing you need to figure out there is you need to figure out which variable is the independent and which variable is the dependent.
N N is the independent?
N is the independent, so typically you know how many pens you're going to buy. So you're going to the store thinking, I need to buy 5 pens. And once you get to the store, you find out how much the pens cost, and it figures out your total cost. I agree with you. I think N is the independent one. Typically, I figure out how many pens I want to buy. So that means N is independent. So that means N is pretending to be the letter X. So when we write ordered pairs here, we have N coming first and C coming second. So if N is coming first and C is coming second, what does 5, 10 mean?
5 pens for $10.
5 pens for $10. That's exactly what it means.
Seems expensive.
Yeah, they're not these cheap Bic pens. They're the good fancy ones. Yeah, $2 a pen.
The school stores like $3 a pen.
Or you bought them here on campus and it's $3 a pen? Okay. You can go to Walmart. Okay, same thing with B. B says, let A be the annual amount of money in millions of dollars Google spent to advertise its own products in the U.S. at T years since the year 2010. What does the ordered pair 1, 2013 mean? All right, so once again, we first need to figure out which variable is independent, which variable is dependent.
T is independent.
T is independent. Usually you're going to know the time. I would agree. If time shows up in your problem, be it years, minutes, seconds, any time value, that's almost always independent. So I think our ordered pairs here are T is independent, so T is the X value, and A is the Y value. So in this case, what would the point 1, 213 mean?
53 hours a year.
So what does the 1 mean?
1 year.
1 year since?
2010.
So that would be in what year?
2011.
In 2011. So in 2011, what does the 213 mean?
13 million.
Google spent $213 million on advertising. Questions on that? Okay, the last thing we have in this section. And we're going to do a lot of this semester. We're going to be given data, and from the data we're going to want to do stuff with it. So this data is the number of automobile accidents for 1,000 licensed drivers per year are shown in the table below. So, 16-year-olds, approximately 190 out of every 1,000 will get in an accident. If you're 17 years old, approximately 163 out of every 1,000 will get into an accident this year. So on and so forth. Now notice later on we come down to age blocks. So if you're between 20 and 29, we decided to pick the value 24 and a half. So if you're between 20 and 29, we're going to assume you're about 24 and a half. 91 out of 1,000 of you are going to get into an accident. So on and so forth. How many people have been in an accident? In fact, I've been in more than one. Only one as a driver, but more than one. Okay, so the first thing it asks us to do is to create a scatter plot. What's a scatter plot or a scattergram?
It's where you're gonna mark all the points.
It's where I'm going to mark all the points. Which points am I going to mark?
You're gonna find out the independent and the dependent.
Excellent. I got to find out the independent and the dependent. So which one's the independent? Age. Age is time, isn't it? That's years. So now, age, am I using this age or am I using that age?
Middle.
The middle one. All right, so we're going to have on our x-axis here, we're going to have age. And so on our y-axis, we're going to have the accident rate. Now, when I go to draw my data, do I want to, on my x-axis here, do I want to go 1, 2, 3, 4, 5 for my tick marks?
No.
No, because I'd have to go way across the page, wouldn't I? So notice we have to go from 16 to 75. So what would be reasonable for my tick marks?
25?
25, 50, 75. That's not using very many of them. I think 25 is maybe a little too big.
15.
Let's see, 15, 30, 45, 60,
You better look
10.
down.
50. I think 10s would be pretty good. That's what I think I would use. 15s would be okay. 25s would work. I just think they're a little too big. So I think I would go with 10s. 10, 20, 30, 40, 50, 60, 70, 80. And I can certainly get to the 75. That's the biggest one I need to get to. Okay, how about on my rate axis? Again, do I want to go 1, 2, 3, 4, 5?
20s.
I definitely don't want to go 1, 2, 3, 4, 5 because I have to get all the way up to 190. So it's 20 is going to be enough. So let's see, 20, 40, 60, 80, 100, 20, 40, 60, 80, 200. I think 20s would be very good. Now, I'm going to be a little bit lazy here. You don't have to label every single one of them. So I'm going to do what I just did. I'm going to go 20, 40, 60, 80, 100, 20, 40, 60, 80, 200. You just have to label enough of them so that somebody reading the graph can understand what the tick marks mean. If you want to label every single one of them, you can, but that's not necessary. Okay, so we go ahead and we mark our data. We've got age 16, 190.3. I can't mark it exactly, can I? I got to kind of estimate. Between 10 and 20, 16 lies there. And then I've got to go up to 190.3. Let's see, that's 180, so that's about right there. So there's a little bit of approximation here, a little bit of little bit of error, but that's okay. Do the best you can. Age 17, we're up to 163. So 17 is just a little bit more than that. There's 180, 163. There's 160, right about there. And I keep going. 18, 142. 19, 127. Then it jumps. Then I go all the way to 24 and a half. 24 and a half is 91. Right about there. 35 and a half, 54. 44 and a half, 43. Like so. And moving on here. 54 and a half, 36. About there maybe. 64 and a half, 31. And 75, 32. Okay, so there would be my scattergram. It would look something like this. Does this data look like it falls into a nice straight line? No. Some data falls into nice straight lines. Some data doesn't. This one doesn't. Questions about that? Questions about how I got those points? What age group has the lowest accident rate? In the 60s, isn't it? 60 had the lowest number, 31.3. 60 to 69. Which group had the highest rate? The 16-year-olds. Between what two consecutive drivers' ages does there seem to be the greatest change in accident rate?
19 and 20.
When you went from 19, you had 127 there. You went down to 91 there, so you dropped about 30 points.
40.
You go to the next one, you dropped almost 40 points, didn't you? You went from 91 to 54, that would be what, 37 points? This one would be 35. So I think the biggest jump is right here. From the 20 to 29 to 30 to 39. I think that's the biggest jump. Does that surprise anybody?
No, it's somewhere
About right. Doesn't surprise me, because I know that what happens when you turn 25?
Or
Insurance rates went
Your
down.
insurance rate drops way down.
Yeah.
How come?
You're halfway to 50.
This is, well, you are halfway to 50, but this is why. This is the sort of thing that insurance companies look at very, very closely. And insurance companies have realized that when people turn around 25, suddenly their accident rate drops way down. What's happening when you're 25? Well, for a lot of people when they turn 25, they're out of college, they're getting a job, they might be getting married, they might be having children. People who are married and have children tend to be a little bit more cautious than 22-year-olds who don't have children and aren't married. At least that was my experience when I was that age. So, very important to insurance companies to know how much should I charge people. And that's why when people turn 25, especially men, when men turn 25, their insurance rate goes way, way down. Because the number of accidents they cause goes way, way down. Questions about that? Women, it happens earlier, I believe. The accident rate for women, I think, goes way down at around 21 or 22. So women get an insurance break earlier. I guess they grow up faster. Questions on anything?